Cool. So my name is Dylan. Oops. I'm an engineering manager on a team called Vivaldi within Spotify. We work in the finance department. And I'm also the tech lead on a project called One Model. And so that's what this is about. And One Model is really powered by Flyte. And so a little bit of a disclaimer here. This presentation is kind of a Frankenstein between a few different presentations on this topic. I tried to stitch them together into a coherent story, but you guys are really the guinea pigs. A lot of this stuff too is also kind of the latest thinking on how we're thinking about this problem. And so some of it's more well-formed than others, but we think it's pretty exciting. So quickly, a bit of background about what we're talking about. Oops. This slide is really about how this project is actually not just this team, but a collaboration of a number of teams within Spotify. And I'll talk a bit about how Flyte actually empowers this. But we're the team in the middle here, Vivaldi, but we also work with, I think, a bunch of the guys you know from Spotify who are contributing towards Flyte itself and managing it within Spotify. We're building a bit of a platform on top of Flyte, and then the team on the top that you see here is actually, and there's a bunch of teams actually in this area, but they are largely comprised of data scientists and analysts, and so not necessarily engineers, but they are our biggest stakeholders, and I'll talk about how that works in a second. But before I do that, I just want to give some background on what we're talking about. So this is really, One Model is a financial forecasting problem. And quickly, what financial forecasting is every quarter, as part of compliance objectives, Spotify is required to project 2 years into the future what we think our profit and losses are. And that's part of just being a public company. And so it's basically a projection across all of Spotify's various business processes. What revenues do we think we'll take in? What costs do we think we'll have to spend in order to get there? As in addition to just being part of a requirement, it also forms a big part of Spotify's business planning. You can imagine this is useful for investors. It's just as useful internally for the people making decisions, the C-suite, et cetera. Unfortunately, it's organically evolved over the years to be a bunch of different heterogeneous processes across many different teams. As you might imagine, Spotify is a pretty complicated company. We have a lot of different products. We work in a lot of different markets. We deal with licensors, music law, stuff like that. And so the expertise in order to kind of run this system is scattered across a lot of different domain experts. And so as it stands, this process takes about 3 to 4 weeks every quarter, span as many as 8 different teams. These teams work in silos. Some of these pieces are Excel models. And then at the end of the day, you might imagine team 1 is handing off a Google sheet to team 2 to start running, if the number of subscribers we get is input to the amount of revenue we think we're going to get, team 1 has to hand that off to team 2. And so it's a complicated process. And so goal number 1 that we're really trying to accomplish, it may be obvious, but it's an automation problem. We want to fix these manual handoffs. We want to speed up the feedback time to do this process, and we want to reduce for errors. And a secondary piece of this is that because it takes so long to run, we can only really do this once per quarter. It's too much of an effort investment. And so we think by automating this, we can really unlock the second piece of the problem, which is business casing and scenario analysis. If we can run this problem end to end, within a couple hours, then these people making the decisions can come in and say, well, what happens if we increase, our subs by 20 million people in India versus what happens if we open a new market in Eastern Europe or something like that. So you can start to ask these questions more frequently. without having humans in the loop in order to answer them. There we go. So this is high level overview, what it looks like. Again, it's a complicated process. Each of these nodes in this graph is actually, this isn't one Flyte task per se. It's a bunch of different things. These are just high level logical pieces to Spotify's business model. And as you can see here, each individual one of these might be owned by a different team. And there's lots of, complex dependencies between teams. And there's no, this is our best shot at what this thing looks like. There's no person who's in charge of the overall end-to-end thing who knows exactly what this looks like. It's very much a distributed ownership model. So yeah, one model, automating all the components. And once we do that, we can kind of unlock this scenario, this business case and analysis scenario. And, we think that'll be really cool. Really quickly, I thought this slide was fun. Why did we pick Flyte? This is actually written by our data science team. So this is not from us, but we think it's really cool because as engineers, a lot of this might be kind of table stakes for us, but for the data scientists, being able to get up and running on Flyte and getting all of this stuff for free has been a really big win for them. And they've been really excited about it. The ability to share models with each other and compose things easily. Out of the box parallelism, again, may not seem like the biggest deal, but for them, when you're writing Python scripts and everything runs and takes a certain amount of time, whereas now for free, we get parallelism across tasks. I think they think that's really cool. The caching, just connectivity with GCS, all of this stuff. They've been really excited about it. So that was the overview, I guess, of one model and forecasting at Spotify. I wanted to talk a bit deeper about kind of the problems we're wrestling with right now and how we're thinking about them, and then kind of how they pertain back to Flyte as our main runtime engine. So quick reminder that this is really a distributed process. Forecast is run by a lot of different teams running in parallel. There's intersection API points between them, but each of these might be a lot of different sub workflows being worked on by many different people. And there's really a human in the loop in between each of these connection points. So subscribers may finish their forecast. They need to do some validation on the outputs. Does this really match expectations? Once that's ready, premium revenue can pick it up, and they have a similar process. The other thing I want to point out here is that there's really two pieces to one model as a system. The first is this forecasting engine, Flyte. So each of these nodes, jump back. Each of these nodes in the graph is like a Flyte workflow, is the way that we're moving. And so this is really the Flyte piece of it. But there's a second piece which is equally important. There we go. It's moving a little slow. Which is what we call the assumptions bank. And these are really, if we think of model developers encoding business logic, business analysts are encoding assumptions in these tabular data formats, which really reflect kind of their best judgment on what the future will look like across a lot of different parameters. So one of the things you might expect is that Spotify may increase its prices at some point a year in the future. We need to encode that as an input to the system. Spotify might launch a marketing campaign in Europe that we expect to bring in, 20 million new free users. These are inputs to the system that reflect our best understanding of the business that we can then run through the forecasting engine itself and get the expected outputs to all this stuff. And so those are the two pieces that kind of happen in the quarterly forecast. Additionally, in kind of the business casing section, you might imagine that someone wants to say, well, what if I change the prices? What is the impact of that? Or, other sorts of such questions. So assumptions bank you can think of as the levers you can pull on a forecasting or scenario analysis process that will change the outcome. And then the forecasts themselves, you can think of as our best understanding of how our business processes actually work internally. So how's it going to work on top of Flyte? Again, this is a distributed process, so it opens a lot of sticky questions. It's really nice. We can say we can automate all this stuff, but really, this is a manual process that requires a lot of validation, has a lot of compliance concerns. We have these user and loop workflows that require validation of each step of the process before it can be consumed downstream. We need to basically bless certain versions of each forecast and then advance them downstream. Those might get updated. How do we handle that? How do we continue handling that with system reproducibility? How do we ensure consistency across this? If someone runs a certain version with a given pricing assumption, and then someone consumes that downstream, and then those assumptions change upstream, how do we handle that? And then, yeah, this again, there's about 25 different people, I think, or more involved in this process every quarter. And so how do we handle that complexity with so many users kind of fiddling with the inputs? So this is kind of where our latest thinking has taken us on this problem. And we really think about it as a problem of like iterative alignment or collaborative development. So if we think of the whole one model system as just this graph, and it's a graph of two different nodes, the first type of node here we have are the assumptions themselves that we're showing in red. And so there are certain users that have their business experts, they maybe run the marketing department or something like that, and they're saying, these are the campaigns that are coming up, here's what I expect them to bring in. They might be people modeling out growth projections in certain areas and then encoding those in a tabular data set. Could be any kind of thing. Licensor contracts is another good one. We have people who work with the licensors. We know which contracts are going to change or what our expectations are there. And then there's kind of the model developers, and these are like data scientists. They know a good amount of Python, and they're really encoding the business logic. That business logic may change every quarter. It may change during a given forecast if we look at an output and say we're missing something here. And so there's lots of different people kind of editing this graph all at the same time and trying to align on, what is the correct state of this graph at any given time. The only other thing I'll mention here is that obviously we have a lot of facts data sets that kind of make the backbone of like our forecasting projections. So you might expect historical MAU to be the input that impacts what I think our organic growth will look like going forward. So what we've really begun to think of this as, again, is an alignment on the state of this graph that users are kind of collaboratively updating. And so if we think of this graph as an immutable object, this really begins to feel like a Git workflow. And so if you can imagine, we have a master branch where this output of last forecast, known as the F3, which is actually the Q2 forecast, but is the head of master. And so what we want to do when we start thinking about the F4 is we make a branch off of the F3, and we start iterating on like the new business encodings, our new updates to these assumptions. Hopefully last quarter's assumptions provide a good baseline. We can make corrections where we're wrong. And we can think about different people owning different subsections of this graph. For example, someone might be the expert on pricing, someone might know how royalties work, et cetera. And we can make these local copies and then commit back to sort of a feature branch, which is iterating towards the next latest forecast. And we can imagine that the head of this branch is always our best guess at what the forecast should look like. And when all the various business owners have signed off, it's something that we can merge back to master and say, this is official, this is what we're sending to Wall Street. And so you can think of the process this way. Similarly, for a scenario analysis, this might just be someone creating a personal bench that never gets merged back, and they can iterate, they can share, all of that stuff. We get a lot of the benefits of normal, collaborative development amongst coders. So yeah, what is actually being committed to this hypothetical Git repo or Git-like workflow? So if we again take a look back at our object model, we can see that we have a couple Flyte workflows in here that each of these things are versioned, right? And they have some sort of dependency graph on each other. And then we also have these assumptions that have like versions themselves. And so we can imagine someone, multiple people taking a look at different parts of this graph. And let's say, someone updates the licensor contracts and creates a new version, and they update the revenue to be V3 down there, we can see. And then they do a run. So we commit this graph back to the repository, and we can see, the top pieces of the graph have not changed at all, but these other pieces have. And so we have, new pointers to each of these nodes in the graph. And when we run stuff in Flyte, we can see, we're going to leverage caching because this top part of the graph has not changed at all. So revenue V3 will change because rerun because it's changed. Royalties hasn't changed, but it will rerun because we have new versions of each of the upstream inputs. And so now our latest best understanding of what the forecast looks like is the output of all the nodes in the graph on the right. And yeah, so there's a lot of benefits to thinking about this way. It allows us to natively enforce the coherency of the system. So we know that the head of this Git tree in a given branch is always going to be internally coherent in terms of what were all the inputs that were run and what were all the outputs that were used. And then it's natively reproducible. We can always jump back to a prior forecast. If anytime we get audited, what it was run as of forecast F3, it's just whatever the Git tag is on the 2021 F3 forecast. It's natively composable, shareable. You can share your business case scenario. You can share your latest state of the forecast, but just pointing to a Git commit. And then the last thing that I didn't really talk in too much depth about is that it makes Flyte caching trivial. And this is something I know I've shared with Keaton a bit, and we've been wrestling, but there are issues around how we make assumptions inputs to the system, because Flyte caching requires you or runs off a specific location on disk. And so even if the data hasn't changed, if you create a new copy of the assumptions, you're going to break, the whole cache. So the nice thing here is actually assumptions now are just a pointer to a Git commit and a specific object in the tree. And they're only going to change, if a user is actually editing that specific file, or in this case, data set. And so, yeah, I think this is kind of our high level thinking around how everything works. The fact that Flyte supports all of these immutable models, all this versioning, and like this entire graph workflow end to end allows us to just think about the state of this graph and then rest on the fact that Flyte is going to keep these things coherent, is going to cache things correctly, and that all of these things end up in some sort of a mutable record within Flyte as well. So that's that. I think I have time for any questions if anybody has any. Was everybody keeping an eye on the time? Oh yeah, not bad.
Firstly, thank you. That gave me a lot more understanding of what you were doing and some of your questions. But I'll let everybody else please ask questions. I will have a couple. No questions. Okay. So Dylan, so when you say you have that graph of the interaction model for the entire forecasting engine, Would it, like, I think it's more of a feature question over here, but would it help for you to visualize the entire dependency graph? Because currently you can't do that today in the console, Flyte console. You only see that at runtime. So would that help to visualize that ahead of time?
Yeah, so I didn't go into kind of user interface here. This is kind of like our thinking on the data model on the back end. Somehow I jumped past this slide, actually. Whoops, I don't know how that happened. But yes, the answer is yes. We may have to implement some piece of this ourselves. In fact, more than likely, we will not be using the Flyte console at all. That said, being able to fetch the end-to-end graph in some representation is definitely useful for us. We'll end up having to build, like, to support this. I somehow skipped over the slide, but in order to support this workflow correctly, again, our users are analysts, and so they're not really familiar with Git workflows. We'll need a UI on top of this, and as part of that, we want to represent, the entirety of the system so that people can understand and reason about it.
Yeah, I'll also add, hey, it is Varun here on Dylan's team, that a sort of compile time or registration time graph would allow us to reason about, for a given model that consumes upstream inputs, right? We'd like to be able to fetch those upstreams for a given model so we can do other things with respect to their relationship to assumptions. So also adding a yes to that would be helpful.
Yeah.
Good.
Yeah, what we really want, and I think we can pull this out of the Flyte API right now. It's just like kind of it's a little bit of work, but we want for any run, like given a run ID, we want to know. I mean, as Varun said, we want to know the state at registration time too, but we want, given a run ID, like which version of each of these nodes was run, what were all of the inputs in terms of the assumptions, as well as historical actuals, and then what were all of the outputs. So we just want like the whole graph. And I think it can be done by iterating through like Flyte objects and the protobufs, but it's not super straightforward.
So it's a great thing. So basically, I don't know if you guys have used Flyte CTL, which we should talk about probably the next meeting. We will talk about Flyte CTL. Has undergone a lot of work, and there's a lot of support. As you know, we don't have in our community, interestingly, we don't have too many people working on the UI. So we actually make Flyte CTL as the de facto interaction piece with the Flyte backend. And of course, that doesn't mean we are not doing anything in the console. I think we have one engineer now who's going to work on a lot of the stuff. And he showed me a great preview of the graphing stuff yesterday. So hopefully we can come and do a demo of the thinking over there in a bit too. But you can use Flyte CTL and it should retrieve all the graph, and it uses GraphViz to actually visualize the entire graph of how it is.
Oh, really?
It exists, and it uses graph.flyte.org. That's endpoint hosted on our on the open source DNS itself. That completely stateless visualization of the graph. So please try it out.
This might be something that's worth linking to in our Slack channel, because I think this is something we're going to want to look at.
Yeah. And actually the source code is in Go, so you can, and it actually prints out a dot graph. So if you have a GraphViz render or somewhere else, you can use that too. So that's one. Secondly, I actually have been hearing a lot of folks ask about the same question, like how do we interact with the Flyte API as a kind of construct graphs or get data for a graph or something. Like even Soren today morning, a couple weeks ago, not even a couple days ago, somebody else, then a week ago, it was Kenny Workman, and so on. And I think FlyteKit, before the new version of the FlyteKit, which is the new API, FlyteKit has the capability of talking with backend and retrieving data and interacting like through a Jupyter notebook or any kind of a programmatic interface. It's just that we are reworking that interface, and Niels here is actually working on I want to say a much more ergonomic interface in interacting with the model. I think Niels, if you can share the RFC in the Slack, we can solicit feedback as to what you guys think, and then also contributions, of course, welcome. So that should ease, like, building, getting data, like reasoning things about. Third thing, Dylan, I had one more question. Again, another feature question, because I saw that it seems that you do have some human in the loop type of actions.
Mm-hmm.
Would it, like, how are you thinking about that rather than me giving an answer?
Yeah, it's a good question. I think it's actually the biggest open question in terms of our next step here is really we want to test this in the wild, this kind of workflow. If you look, the human in the loop here is really someone will run their model, and then they'll have to verify the output before giving it downstream, and then that may happen iteratively as downstreams notice there are issues. They may need to run upstreams. Exactly how we handle that in terms of a workflow that is, good for our users, I think we'll have to build a lot of UI on top of to make it not a bad experience. We're hoping the Git model underneath will handle like the internal coherency and correctness of the system. How we make it like a pleasurable experience for users, I think, is an open question. It's ongoing research right now. So I don't know if that answered your question, but it's something we're thinking about.
It gave me some hints. So one thing I will. Okay, so once we open source Flyte, probably in the first month, somebody asked, "Can we get human in the loop tasks?" And that's one of the reasons why I brought this up. The use case that what I've heard of in the past for human in the loop was essentially something like labeling, right? Like you get a data set, and then there is a person who actually labels it or approves the labels, and that needs a human today.
Mm-hmm.
And it's kind of your stuff also, like you get the data and then you kind of approve the data, right? You just like either this is right or no, go ahead, right? It's like a barricade. Is that the right way of thinking about it? Or not a barricade, a barrier?
Yeah, I think that's true. I think honestly, we were probably planning on handling that outside of Flyte. So thinking about how Flyte could handle it for us isn't really something that we've thought about. But generally, if we jump back to here, one of the nice things about this is that, if someone makes some changes that update something that needs to be reapproved, it's very easy to understand and track. And so we can say, oh, it looks like there's changes to this assumption that you are an owner on. It needs to be reapproved. At the end of the day, everything at the head of this branch needs to be signed off and approved by a business owner. And so exactly what that looks like, I don't know. The nice thing is this allows us to at least understand the current state of a system and what is like not in sync and stuff like that. But the best workflow, I'm not sure.
Okay, that's awesome. Yeah, it gives me a lot of thinking to do in the human in the loop, because we have evolved our thinking in that direction as well. I don't think we will be implementing everything as you said. What we'll be doing is giving the right set of tools so that folks like you can actually just implement the right interface for their users.
Mm-hmm.
Because I think that interface changes between, let's say, the labeling and your use case and some other use cases, right? They are all kind of slightly different, even though the mechanics are the same. The interface is different.
Yeah, one of the things we want to be able to do is compare the outputs of two runs. And so if something gets modified and rerun as part of just like the process, it should be fairly quick for someone to take a look at the difference and sign off on like any changes. But again, I think that might be external to Flyte as a system. I'm not sure. Maybe it's not.
I think The human in the loop, as I said, was asked, and I think it's pretty useful for certain interesting use cases. So, any other questions? Anybody?
Then you should look at how Rippling is doing it, which is interesting. Our payroll system basically has a human in the loop sort of built into it, and it essentially ties a task to an email address and then a set of you set a nag frequency on how often emails go to the person, and then it's a pretty simple model, but it kind of works. I don't know. It's a totally interesting problem to think about.
Yeah, but that's the interface, right? The engine can handle this, like just saying that, hey, I'm waiting for a signal. And you send the signal as an email, as a click on the button in a UI somewhere.
Yeah, but it doesn't have the concept of a person, a timeout,
Yeah.
and a nag frequency.
Yeah.
So I mean, it's like a named task type, human. Hey, cool
Yeah, I
problem.
mean, one thing I can think of is more granular ownership of like components, whether that be at like the task workflow level. I know permissioning is another one that I think like we're since we're not exposing Flyte directly to users, I think we'll be able to get around it, but like having better permissioning controls built into the framework would just be very nice, I think.
Yep. Role-based access control.
Yeah, exactly.
Of the hot topics. Cool. Yeah, I think we're getting into a lot of feature discussion, but if there are no other questions, I wanted to open up and like have a open chat with lots of folks. I will take notes. And then we would like to present the study and like probably a roadmap on the next meeting that we do based on this. So open up for either questions on this or just in general questions or features that you think are really that would help your business. If there is no talk. So all the features exist. Awesome. So we can stop building, go home. Anyways, let me talk about what we are working on, at least the core team. We've been.
I think Sandra had like a survey with like a few probing questions maybe that might get people thinking about what topics they might be interested in. I don't know if you want to post that here, give them a 30 seconds or a minute to just answer that.
Sure, yep. I have the link in the chat. I can drop that in. Would you like to do that now, Keaton?
Yeah, please do. Go ahead. That'd be awesome.
I have some other random stuff we've been thinking about. I don't know what the scope of this conversation is.
No, this is open-ended. We actually have not done an open-ended conversation for a while, and we just wanted it to be like a place where everybody can just share whatever they would like to. So please go ahead.
One of the things, yeah, I think again, because this is a distributed system that we're wrestling with how to deal with is when we have all these multiple contributors contributing these models with these like interfaces between them, thinking about how to define better like an encapsulation, I guess. So along like with the permissioning and stuff like that, you could imagine public and private models. And then, schema compatibility, somehow enforcing that. I don't really know, or like compatibility checks, enhancing the way that functions within the system could be very interesting as well. Especially because, and this is maybe unique to us because our users are data scientists. I don't think they really think in these ways, and because we can't encode it in the system ourselves, it's like a little nerve-wracking about how this is going to function. You know, if it's a bunch of engineers, I think they're capable of enforcing these things themselves. But even then, it would be nice to get like some free, you know, correctness checking, like at registration time or something like that.
And so, and this is schema specifically with respect to schema, right?
Well, there were like two things, right? Like you could have many tasks and workflows, but only want some of them to be consumable and some of them to be like really visible. And those are like those are like the interfaces that you define. And then you could refactor at whim like the other tasks or workflows that like comprise your private, you know, part of your graph. But right now it kind of just all shows up as equal components in the Flyte console.
Right.
And then another thing that we've run into is if you then refactor things, you know, nothing ever gets deleted. And so it just, the Flyte console just has every record of all your history. And it's difficult to, you know, go through and understand which pieces of the system are kind of like the high level, like interface, I guess, just keep using that word, and which pieces are just kind of like things that, yeah, are less important.
Is it like a, if I have to rephrase your question, or yeah, let me rephrase it. So you're saying that essentially you want a way to delineate what is exported by a project to as a consumable task.
Yes.
Workflow.
Yep.
Yeah. And do you think that ties into permissions in some way?
It could, right? Because, you know, if there's like, I should be able to run anything that's like private in my repo or my project or whatever, but others should not be.
Yeah.
But if I designate, you know, someone has the rights to run my public things, that could potentially be like, you know, part of role-based access. So I think they're intersecting, but maybe not one and the same.
Yep.
It would be kind of cool if we could, going down this idea of permissions, have some sort of, you know, in the theme of declarative infrastructure, right? For a given workflow, declare different levels of permissions, you know, user versus editor versus owner. And then for each role, we could assign like IAM group owners. I guess, Dylan, that's what you mean by role-based permissions, right? But if we could have that as a sort of Flyte config that we could check into a version repository, and that means that it's really easy to modify those.
Yeah, that makes sense. Yep. I think so. Some time ago, we actually went, before creating the idea of reference tasks, we thought about having an export, like you do in C or some other languages, right, where you could say extern, right? Only those things are available outside. We thought about that, but then we quickly realized that actually it needs permissions to really, because exporting is one thing, but after that also you may not want to export to everybody. You may want to export to some people only. But I think maybe, as you're saying, we can at least export as an idea. So, okay, that's awesome.
I think you could do, yeah, without permissions, right? It's just like, don't allow things that aren't marked exported to be fetched from the central.
Yeah. It's just that it would be weird that you can see everything, but you can't really put it. Right? So visualization, we can visualize it probably, like export it as a separate section. But today, since everything's open in the permissions model on the control plane, you can access all the entities, right? So there's, but I like the idea of external. Okay. But that would be a breaking change. So let's say if we introduce externing as a thing, if you're using already stuff, you will have, if you check in or if you pull in the new control plane, you'll need to
Yeah, you need to do it the other way around, which is just mark stuff private.
Yeah.